We think of oxygen as essential for life, for breathing, and for combustion. It's the element that fuels our very existence and powers the flames that light our world. But could this ubiquitous element also hold the key to reducing friction in machines? It's a question that has intrigued scientists and engineers alike. It might sound strange, but recent research suggests that oxygen, under the right conditions, can act as a lubricant. This discovery could revolutionize the way we think about machine maintenance. Traditional lubricants like oil and grease have served us well, but they have limitations. They are prone to breaking down under stress and can be messy to handle. They can break down at high temperatures, are not environmentally friendly, and often contribute to pollution and waste. Additionally, they can be inefficient in certain applications, leading to increased wear and tear on machinery. Oxygen, on the other hand, is readily available, environmentally benign, and offers a cleaner alternative. It can withstand extreme temperatures, making it suitable for high-stress environments where traditional lubricants fail. The concept of using oxygen as a lubricant is based on its ability to form a thin oxide layer on the surface of some materials. This layer acts as a protective shield. This oxide layer can act as a barrier between two surfaces in contact, reducing friction and wear, and potentially extending the life of machinery. However, harnessing oxygen's lubricating potential is not straightforward. It involves a series of precise scientific processes. It requires carefully controlled conditions, precise oxygen flow regulation, and meticulous monitoring to ensure optimal performance, and a deep understanding of the interaction between oxygen and different materials. This ongoing research could pave the way for more sustainable and efficient industrial practices in the future. Before we delve into the experimental setup, it's crucial to emphasize the importance of safety when working with high-pressure oxygen. Safety is not just a protocol, but a fundamental aspect of our work. Oxygen is a highly reactive element, and at high pressures, even a small spark can lead to a dangerous combustion reaction. This is why we take every precaution to prevent such incidents. Our experimental setup is designed with safety as the top priority. Every piece of equipment is checked and rechecked to ensure it meets stringent safety standards. The oxygen is stored in a securely fastened high-pressure cylinder equipped with a pressure regulator and a flow meter. These devices help us maintain control over the oxygen flow and pressure. The entire experiment is conducted inside a fume hood with a fire suppression system to mitigate any potential risks. This ensures that any accidental ignition is quickly contained. The experimental apparatus itself consists of a tribometer, a device specifically designed to measure friction, wear, and lubrication properties of materials. It is an essential tool in our research. The tribometer allows us to control the contact pressure, sliding speed and temperature between two surfaces, while simultaneously measuring the frictional force. This precise control is crucial for obtaining accurate and reliable data. With safety measures in place, the next step is to regulate the flow of oxygen. The oxygen cylinder is fitted with a pressure regulator that allows us to control the pressure of the oxygen being delivered to the tribometer. A mass flow controller is used to precisely regulate the flow rate of oxygen. This device ensures a constant and accurate flow of oxygen to the contact area between the two surfaces being tested. The controlled flow of oxygen is directed to the contact interface between the two surfaces under investigation within the tribometer. The oxygen under pressure forms a thin layer between the surfaces. This layer is what we believe provides the lubricating effect. Section 4. Measuring friction, the tribometer in action. At the heart of our experiment lies the tribometer, an advanced instrument that allows us to simulate the conditions of friction and wear experienced in real-world applications. This device is crucial for understanding how materials behave under stress. The tribometer consists of two key components, a stationary surface and a moving surface. These components work together to replicate the frictional interactions that occur in various environments. In our experiment, the stationary surface is a steel disc, while the moving surface is a steel pin that is brought into contact with the disc. This setup mimics the contact points found in many mechanical systems. The tribometer allows us to control the force with which the pin is pressed against the disc, simulating different loads. By adjusting the load, we can study how varying pressures affect friction and wear, As the pin slides against the disc, the tribometer precisely measures the frictional force between the two surfaces. This measurement is critical for predicting the performance and longevity of materials. This data is continuously recorded and displayed on a computer screen, allowing us to monitor the friction behavior in real time. The real-time data helps us make immediate adjustments and understand the dynamic changes in friction. Section 5. Analyzing the results. Oxygen's performance. After conducting the experiment under various conditions, we analyze the data collected by the tribometer. The results are intriguing, suggesting that oxygen does indeed possess lubricating properties. In the presence of oxygen, we observed a significant reduction in the coefficient of friction, a measure of how easily two surfaces slide over each other. This reduction in friction indicates that oxygen is acting as a lubricant, reducing the resistance between the moving surfaces. Furthermore, the wear scars on the steel surfaces were visibly reduced when oxygen was used. This suggests that oxygen not only reduces friction, but also protects the surfaces from wear and tear, potentially extending the lifespan of machinery. Section 6. The future of lubrication, oxygen's potential. The results of our experiment open up exciting possibilities for the future of lubrication. Oxygen, with its abundance, environmental friendliness, and high-temperature stability, could revolutionize how we reduce friction in various industries. Imagine engines that require less maintenance, machines that operate with higher efficiency, and manufacturing processes that are cleaner and more sustainable. Oxygen lubrication has the potential to transform industries ranging from aerospace and automotive to manufacturing and energy. However, further research is needed to fully understand the mechanisms of oxygen lubrication and to develop practical applications. We need to explore how different materials interact with oxygen under various conditions and optimize the oxygen flow and pressure for different applications. Section 7. Final thoughts. A breath of fresh air for engineering. The use of oxygen as a lubricant while still in its early stages presents a fascinating example of how scientific curiosity and exploration can lead to unexpected discoveries with the potential to reshape our world. As we continue to push the boundaries of our understanding, we may find that solutions to some of our greatest challenges lie in the most unexpected places. Sometimes all it takes is a breath of fresh air, or in this case, a stream of pure oxygen, to unlock a world of possibilities.